Hello and welcome back to Computer Science and Engineering 120 Learning to Code. This is Module 10, Processing Data Part 2, using array and string processing functions. In Part 1, we'll focus on how to process arrays using built-in functions, including functions that allow you to modify arrays by adding or removing elements, as well as more sophisticated functions such as map, reduce, and filter. There are several functions that support modifying arrays, including adding and removing elements. Two simple functions are push and pop. They operate by allowing you to add an element to the end of the array, or to remove an element from the end of the array. The pop function returns the element so that you can capture it into a variable. Push and pop are common operations when dealing with a data structure called a stack, which offers a last in, first out ordering of elements. The last one that you put in is the first one out because you're adding and removing from the same end. Similar functions include unshift and shift, which allow you to add an element to the start of an array or remove and return an element from the start of an array. Using a combination of push and shift can give you a different data structure called a queue, which offers a first in, first out ordering. Stacks and queues are fundamental data structures that are common to many applications. More generally, you can use the splice function, which takes several arguments. It allows you to add and remove any number of elements from anywhere in the array. The first argument is the index at which you want the operation to occur. The second argument is the number of elements that you actually want to remove from the array. If you're adding elements, this number will be 0. All subsequent arguments are the elements that you want to add to the array. You can provide as many as you want, including 0 if you just want to remove things. Let's take a look at some examples. Here I've created an array of 5 elements, 10, 20, 30, 40, and 50. Let's push an element into the array. We'll go ahead and push the element 15, and it should appear at the end of the array. And we have 10, 20, 30, 40, 50, and now 15 at the end. If we execute it again, we should have 2 copies of 15 at the end. Duplicates are allowed in arrays. Let's push a different element, 5. And 5 now appears at the end of the array. We can pop an element and capture it into a variable. The element is gone from the array, but it is now in the variable x. Let's reset our array and look at shift and unshift. Now 15 is at the front of the array. Adding 5 after 15 means that it is again at the beginning. Shift removes the element at the beginning, and you can capture it into a variable. 5 is now gone, but it is stored in the variable x. Let's again reset our array and look at splice. Arguments of 0 and 3 means that we will remove 3 elements starting at the index 0. So 10, 20, and 30 will all be removed. And we are left with 40, 50. Let's reset our array and start at a different index, 2. This will start at the third element, removing 3 elements, 30, 40, and 50. And we're left with 10 and 20. Let's reset our array and insert 5 and 15 at the beginning of the array. 5, 15, 10, 20, 30, 40, 50. Let's start at a different index, 4. Resetting our array first. Now it's 5, 15 has been inserted in between 40 and 50. You can essentially replace by adding and removing at the same time. Here we'll remove 2 elements starting at index 0, replacing them with 5 and 15. Any number of these combinations allows you to manipulate the elements of an array anywhere you like. The map function is a function that operates on an array that also takes a callback. That callback is applied to each element on the array, returning a new value. The result is a new array containing the returned values. Let's take a look at this example in action. Here we've got an array with 10, 20, 30, and 40. The callback function that we're giving it takes the value, the index of the value, and the original array that you're calling this on, in this case ARR. The function itself will process values in the array, 10, and then 20, and then 30, and then 40, applying whatever code you place inside this callback. In this instance, we're simply multiplying the value by 2 and then returning it. The map function returns a new array containing elements returned by the callback. In this instance, it'll process 10 and multiply it by 2, returning 20. Then it'll process 20, multiply it by 2, returning 40. 30 will return into 60, 40 will turn into 80. The original array is unchanged. Only the new array contains the new values. Let's apply it. The original array is still 10, 20, 30, and 40, but the new array contains everything that is now doubled. The reduce function iterates over elements and aggregates them, rather than processing each one individually. It takes a callback that has both a previous value and a current value. That current value is the element in the array. The returned value is carried over into the next callback call. An initial value can also be provided. Let's take a look at this useful example. Here we've got an array of strings, Margaret, Hamilton, and her birth date. We're going to apply the reduce function on this array to aggregate the values into one string that represents the row of an HTML table. In this instance, we've got a previous value, pval, a current value, cval, an index, and an array. We won't use the index or the array. Instead, we'll take the previous value, concatenate a table data element, concatenate the current value within the table element, and then close it off. Our initial value will be the HTML row table beginning tag. Then, after the entire function executes, it returns a string. We then concatenate the closing table row HTML tag. Let's see this in action. Again, the way that this operates is that it aggregates the elements in the array. An initial value of table row is passed to the first callback. Then, the current value is Margaret, and the previous value is the table row HTML element. So we concatenate a table data element with the current value and a table data closing tag, giving us tr, td, Margaret, and closing td. Then on the next element in the array, Hamilton, the process repeats, and we have another table data element. A last table data element on the last element, which happens to be the birth date, and then we close it off with a table row. The filter function also iterates over elements and either retains or ignores them to create a new array. Like the previous two examples, it takes a callback. But the expectation for this callback is that it returns true if you want to retain the element, and false if you do not want to retain the element. The new array that it produces is the array of retained values, values for which when you process them, you return true. Here we have that example. We apply filter to our array here, which is 5, 8, -2, 0, 4, -4, and 8. The callback function takes a value, the index of the value, and the original array if you need it. In this case, all we're doing is checking to see that the value is positive. If it is, we return true. We should retain positive elements. Otherwise, we return false. We will ignore 0 and negative elements. When we do this, the original array is unchanged. However, the new array that it returns contains the elements in the original array according to the filter. Only the positive elements are retained. The original order is also still maintained.